Hi everyone. So today is day 12 of the September LeetCoding Challenge 2021, and on this day we have to solve this problem. This is basically like the title of this problem is Reachable Nodes in Subdivided Graph, and as the title suggests, in this problem we have been given an undirected graph, and basically the undirected graph will be referred as original graph, and the original graph has got n nodes, and all these nodes are labeled from 0 to n minus 1. And we have decided to subdivide each edge in the graph into a chain of nodes. So basically, if the original graph is this, then we are inserting some number of nodes between each pair of nodes to divide every edge into a number of edges. So in this example, like this edge is divided into two parts, and like the number of parts in which we are dividing each edge will be referred like which it will be like conveyed using this variable count. So basically every edge will be given in the form of ui, vi and count I. So ui and vi are basically the number of nodes between which the edge is formed, and this count I is basically the number of nodes we have to insert. So if this quantity is 0, then we are not dividing the edge into any parts, so we are leaving it as it is. And yeah, so like after dividing this graph using the after dividing this graph using this information, we have to tell that how many nodes of this final graph are reachable from the node 0. So a node is reachable only if the distance from the node 0 is max moves or less. So max moves is a variable that will be given as a parameter, and yeah, so that is basically the problem. So we can consider one example. So in this example, like there are 3 nodes, and like we are dividing the edge between 0 and 1. So this is this edge between 0 and 1. So this will be divided into 10. So basically, since this quantity is 10, so there will be 10 nodes will be inserted between this edge in this edge, and these 10 nodes will divide this edge into 11 parts. Similarly, between 0 and 2, we have to insert one node, and this will divide it into 2 edges. And similarly, between 1 and 2, we have to insert, where is 1 and 2? Sorry. So between 0 and 2, we have to insert one edge. So it is 0 and 2. So we have to insert one edge. And between 1 and 2, we have to insert 2 edges. No. Between 0 and 2, we have to insert one node. And this will result in 2 edges. And between 1 and 2, we have to insert 2 nodes. So this will result into 3 edges. So this, and here like there will be 10 nodes as suggested by this final graph. So in the second example, yeah, so in this example, like there are only 13 nodes are reachable from this node 0. So where is node 0? So this is node 0, and only these nodes, the nodes that are colored yellow, are reachable from this node 0, and these 3 nodes, yeah, so these 3 nodes are not reachable. So the reason why it is not reachable, because the max moves is 6. So the max move for this distance for this node will be 1. It will be 2. It will be 3. It will be 4. It will be 5. It will be 6. And for them it will be 7, 8, and 9. Actually, for this it won't be 9, because we can also visit this like node from this path, so it will come out to be 7. So, and it will come out to be 8. So since the distance of these nodes are 7, 8, and 7, so these are not reachable from the node 0. So the answer is 10. So after seeing the example, we can like kind of get an idea how to solve this problem. So like what we will be doing will be, so there are 2 more examples, so those are similar examples. So in this last example, like the node 0 is disconnected from the rest of the graph, so only this node is reachable. So the answer is 1. And here it is a general example, so we can take a look to the constraints. So the number of edges are ranging from 0 to 10 to the power 4, and each edge is basically a collection of 3 integers. So first two are symbolizing the nodes, and third one is symbolizing the number of nodes that are to be inserted between these two nodes. And the nodes are zero based index, like the nodes are following zero based indexing, so they will be having values from 0 to n-1, and there are no multiple edges, and this count is less than equal to 10 to the power 4, and this is less than equal to 10 to the power 9 max moves, and the number of nodes is less than equal to 3000. So after seeing this count, we can tell that so basically every edge will be divided into at max 10 to the power 4 plus 1 parts, and since there will be at most 10 to the power 4 edges, so the maximum distance for any node present in the graph will be less than 10 to the power 9. So we can use 10 to the power 9 in this problem as for symbolizing the infinity. So the idea to solve this problem will be to first find the distance of every original node from the node number 0. So we will be finding the minimum distance of every, so suppose it is u, it is some v, and there may be some other nodes also. So we will first finding the minimum number of, so first of all we will be finding the minimum distance of the nodes from this node 0, and for doing that, what we will be doing, we will use this count of nodes present between these two nodes and add 1 to them and use it as a distance between these two nodes. So what we will be doing, we will be making a graph in which the distance a distance between each, we will be making a weighted graph in which the distance will be acted by this quantity after adding 1. So after doing that, we will have the distances of every node from the edge number 0, and if we know the distance of these two nodes, we can easily find how many nodes in between them are reachable from the node 0. So basically since we know that any node is reachable if it has distance less than or equal to max moves. So this max moves, so the number of nodes reachable from this node will be max moves minus distance of this node. So suppose this distance of this node is 18 and max moves is 19, so we can easily visit this node. So obviously max moves after subtracting this distance will give us the nodes that can be visited along this direction. So just in case this quantity is negative, then we cannot visit any node in this direction. So after subtracting these two quantities, we will take maximum with 0. So this will give us a number of nodes visited that can be visited in this direction, and similarly we can do this along this direction also, and then we'll be adding them, and since it is possible that there may be an overlap between these two nodes, so we will be, after adding, we will be doing minimum with the number of nodes present between them. So this whole expression will give us the number of nodes that are reachable in this edge. So this is the algorithm that we will be using for solving this problem. And as for these nodes, whether these bigger nodes are reachable from the node 0 or not, we have already calculated the distance of every node. So we can just check whether the distance of each node is less than or equal to max moves or not. So if it is less than equal to max moves, then we will increase the count. Otherwise, like it won't contribute to the increment in the count. So this is the algorithm that we'll be using. So we can start implementing it. So first of all, like I will be making a graph. So this graph will be a vector of pairs. So these pairs will contain the next node and the distance or the like edge length to that node. So we can iterate over all the edges. Then we can push the pair of edge 1 and edge 2 plus 1 in the vector of edge 0. So the reason we are doing this because n nodes will be dividing the edge into n plus 1 nodes, n plus 1 edges. So that's why we are doing this. And similarly, we will do it by interchanging the two nodes. Now we need to use the dijkstra algorithm on this graph for calculating the distances. So I will be making a vector for storing the distances also. So I will initialize it with infinity. So as for the infinity, we can easily use a value greater than 10 to the power 9. So I will be using this value for infinity, and yeah. So we have got this distance also, and we have got this infinity also, and we have also got the adjacency list of the graph. Now we will need one more thing, and that is we will need a set. So this set will contain the active points and the first active point will be 0. So I'll be setting the distance of node 0 as 0, and I will then push this. I will have to use insert because it is a set. I'll push the node and its distance. So the first member in this pair is the distance, and other is the node. So the reason why I am using distance first, because it is an ordered set, and so it will be like ordered according to the first member of this pair. So since we are using distance, so it will always give us the node with the lowest distance after doing dot begin. So now we can run our algorithm until this set is empty. So first of all, we will be extracting the node with the lowest distance. So I can call it ITR. So we know that ITR dot first is the distance, and ITR dot second is the node. Now we have got this. We will like check whether all these adjacent points are getting updated or not, like whether we are able to achieve a smaller distance for its neighboring points or not. So I'll be doing auto negh, so neighbor of this node. So we'll be considering every neighbor of this node. So we need to check whether the distance of neigh dot first is greater than the distance of node plus the cost of this, the cost of the edge between the neighboring node and our node. So it will be neigh dot second. So just in case this quantity is less, then we will be updating the distance of this adjacent node. So for that we can do what? We can first remove this neighboring node from the active points. So I need to do this. I'll be also doing this here. So the first thing is always the distance. So it will be any igh dot first. It will be distance of any igh dot first and then any igh dot first. So after removing, we will have to update its distance. So its distance is now equal to this, and then we can again insert this point after updating its distance. So its distance has been updated now, so we can insert it along with its distance and the node number. So this whole while loop will calculate the minimum distance for all the nodes from the node 0. Now we will need a count variable to like calculate the number of nodes reachable from node 0 or not, so we can consider every quantity in distance. So if that val is less than equal to max moves, then we can increase the count, and now we need to count the number of nodes, count the number of these smaller nodes reachable from the node 0. So we will be considering every edge of the edges. So the number of nodes reachable from the first node will be max moves minus distance of the first node. So the first node is S0, and then we need to take maximum with 0 so that this quantity is not negative, and after taking that we can take minimum with the number of nodes present between the edges, so that is S2. So this will give us the number of nodes reachable from the first node, and we can similarly calculate the number of nodes reachable from the second node, and it will be a similar code, just this S0 should be replaced by S1. And now we can increase the count by taking minimum of S2. So basically total number of points between these two nodes, and then we can sum these two quantities. So the reason we are doing this minimum in this line here, because it may be possible that we are counting each node twice. So just in case that that will be done, this quantity will exceed this H2, and since we are doing minimum with H2, we are only counting the desired number of nodes. So now we have got the correct count, we can return it. So we can try to run it on the sample test cases. So there is no member named removed. So actually it is erase. Yeah. So the sample test case is giving correct result. We can submit it. Yeah, it got accepted. So thank you guys.